June 2016, question number 8. It says the diagram below shows the first three figures in a sequence. Each figure is made up of knots and strings. Each knot connects exactly 3 strings. All right, so have a good look at the figures. All right, and what we're being asked to do is being asked to draw figure 4 of the sequence. All right, it's not very difficult actually. Might look difficult, but it isn't. If you sort of start with diagram 1 and sort of build on it, you'll see what I mean. All right, so this would be diagram 1. Then for every diagram now, at the end of the strings, you put a knot and then you add 2 more strings. All right, so this will be diagram 2. Then you put a knot at the end of every string, and then add 2 more strings. This will be diagram 3. Then you put a knot at the end of every string. All right, and then add 2 more strings. All right, when you do that, you would have diagram 4. All right, so it's not so difficult to draw. All right, let's look at the next part of the question. All right, in the next part of the question, we're told that the figure below shows the figure below shows the number of knots and strings in each figure used to draw figures 1, 2, and 3. We're to complete the table by inserting the missing values in the rows numbered I, and I. All right, so we have this table here. We have figure number to the left, which is N. We have knots K, and we have strings S. All right, let's see if we can, well, by simply studying the numbers in each column, we can easily figure out the number that will go here and here. That wouldn't be very difficult. All right, but the one below it might not be so easy. All right, so let's start by see if we can identify the general term. What I observed is that this is 2 to the 1 minus 1, and that gives me 1. Because that is 2 to the power 1 is 2 minus 1, I get 1. This is 2 square minus 1. So that's 4 minus 1 gives me 3. 2 cube, which is 8 minus 1 gives me 7. So I'm going to go with that. This is 2 to the 4th power minus 1. That's 16 minus 1. That gives me 15. So that's my observation. All right. That the value, the number of knots is actually 2 raised to the power of the figure number minus 1, and that gives me the number of knots. Now over here, I observe that this is 2 square minus 1, which gives me 3. So here, the power that you raise 2 to is 1 more than the figure number. So this would be 2 to the 3 minus 1. This is what, 7. 2 to the 4 minus 1, which is 15. So this is 2 to the 5. 5 being 4 plus 1, so it's 1 more than the figure number, minus 1, which gives me 31. That's my observation. Now, for I don't know the figure number, so I'm going to call it x. To get the number of nuts, it's going to be 2 raised to the figure number, which is x, minus 1. And over here, the number of strings would be 2 to the x plus 1. So the power here is always 1 more than the figure number, minus 1, which gives me 255. So I could use that equation to determine the value of x, which is the figure number. So if I say 2 to the x plus 1 is equal to 255, sorry, minus 1. All right, so I forgot something. Minus 1 is equal to 255. I can say 2 to the x plus 1 is equal to 255 plus 1, which is 256. So that now is negative 1 goes over and become positive. Now 2 to the x plus 1 could be written like this. 2 multiplied by 2 to the x is equal to 256. Now this is sort of like a reverse application of this law of indices, which says that a to the m multiplied by a to the n is equal to a to the m plus n. Or if I want, I could say a multiplied by a to the n is equal to a to the n plus 1. So it's sort of a reverse application of this law of indices, which essentially says that if you're multiplying and the base is the same, you must what, add the indices. So the reverse is true. The reverse is true. So it's a reverse application of this. So this and this here, they're the same. All right. Because here this is what, 2 to the 1 multiplied by 2 to the x, and if you're multiplying and the base is the same, you add the indices. So 2 multiplied by 2 to the x is the same as saying 2 to the x plus 1. So then I divide both sides by 2. All right, put clear over here. Divide both sides by 2. I'm going to get 2 to the x is equal to 128. 128 is 32 is 2 to the 5th power. 64 is 2 to the 6th. So 128 is 2 to the 7th. So this is 2 to the 7th 2 to the x is equal to 2 to the 7th. So now if the base is the same, the powers are equal. So this x is equal to 7. So the x here is 7, and this will be 2 to the 7th, which is 128 minus 1. The number here is 127. All right, and that completes that row. All right, now finishing the question shouldn't be that difficult. To get the number here, now we're at row I. The number here, it's going to be what, 2 raised to the figure number, the power figure number, which is the same as the figure number, minus 1. So just use a calculator for this. This is 2 raised to the power 10 minus 1. This is equal to 1023. Now over here, strings, the power the area is 2 is 1 more than the figure number, so that's 2 to the 11th minus 1. So this is equal to 2047. All right. So if there's nothing else, that's the end of the question.